A very good day everyone. We are from group A7. We are here to determine the bending moment and bending stress that act along the bar, and let's continue with the procedure. A bar is fixed between these two planks, and different type of person with different load are asked to hang over the bar, and data are recorded based on the different type of person hanging on the bar and different amount of force exerted on the bar. And let's continue with our team.
Because of the applied loadings, beams develop on the internal shear force and bending moment that in general vary from point to point along the axis of the beam. In order to properly design a beam, it therefore becomes necessary to determine the maximum shear and moment in the beam. One way to do this is to express V and M as functions of their arbitrary position x along the beam's axis. This shear and moment functions can be plotted and represented by graphs called shear moment diagrams. The maximum value of V and M can then be obtained from these graphs. In order to formulate V and M in terms of x, we must choose the origin and the positive direction for x. As you can see now, when a lightweight person hangs on the bar, the bending effect is not that obvious. Now, when a moderately weight person hangs on the bar, the bending effect on the bar can be slightly obviously seen. Now, when a heavier person hangs on the bar, we can see that the bending effect of the bar is obvious. This is the FBD of the pull-up bar. If we can see, the length is 0.827 meters and two single forces are acting on the pull-up bar, and when the two forces are converted into distributed loads along the bar, its value becomes 771.5 Newton meter. Then the pull-up bar is separated into two segments. Both segments of the pull-up bar are equal. In the segment, the length of the whole bar is replaced with L. The length of the segment is replaced with X, and the value of the segment is replaced with F. The force of the segment is replaced with F. Now we will try to solve the forces acting on the segment. An equation is created during the solving. Then we simplify the equation. Now we will try to solve the moments acting on the pull-up bar. So summation of all the moments is equals to 0. Then an equation is created consists of FL over 2 times with the distance of the segment x plus Fx times x over 2 plus m is equal to 0. Then when it simplifies, m is equals to f over 2 bracket lx minus x squared. Then using the first equation, we will try to create a moment shear diagram. First, we must try to find v.0. So the whole equation must be equals to 0 and we must find the value of x. In this case, x is equals to L2. Then we will try to find the maximum moment using the second equation by substituting x with L over 2. Thus we get an equation m max equals to FL squared over 8. Okay, this is the general graph that we get using the equations. The first graph is actually the shear diagram, and the second graph below the shear diagram is actually the moment diagram. Next, to compare the graphs between three different weights, we must substitute the force acting on the beam. Now, to compare the shear and moment diagrams between three different weights hung on the pull-up bar, we need to create specific shear moment diagrams for each weight. For that, we need to substitute the values to find the shear force. Then later plot the shear diagram, followed by the moment diagram. Now we are trying to find the maximum moment for the first person, which is the lightest person hung on the pull-up bar. The force given by him is 687.67 newtons. Value calculate பண்ணுங்க கொஞ்சம் சப்போர்ட். Next, we are drawing the moment diagram. Next, we're going to repeat the same step, but this time we're going to use the moderately weighted person. The force given by him is 686.7 newtons. the value of the shear stress is 283.95 Newton per meter, and the maximum moment is equals to 58.71 Newton per meter squared. Next, we are going to sketch the shear diagram. Steeper. Now, this is the sketched shear diagram, and below it is the sketched moment diagram. Now we are trying to find the shear force for the heaviest person hung on the bar, followed by the maximum moment. The force exerted by the heaviest person is 784.8 newtons. The shear force is equals to 824.5 Newton per meter, and the maximum moment is equals to 67.09 Newton per meter squared. Next, the shear diagram and the moment diagram are sketched. The shear diagram for the lightest person shows that it's getting steeper. It's not that steep when you compare with the person which has the shear diagram where it shows the graph is more steep. And when you look at the moment diagram, the peak of the curve is getting higher as the person's weight increase. So this actually shows the tendency for it to bend. The higher the peak, the more the bar bends. In conclusion, it is important to study the bending stress and moment along beams. So that it could be applied in our daily lives. By knowing this, we are able to determine the maximum shear and moment of a certain beam in order to build stronger structures and reduce failures. Thank you.